Back to Further Solutions Academy. Further Solutions Academy. On this video, I'll be walking you through linear mapping. Don't forget to share and subscribe. If you have not subscribed before, kindly share and subscribe to our channel. You can comment below just in case you need any of our attention or our online class. We are always there for you. The outline of this video, number one, I'm talking about definition of what linear mapping, and the second one is examples. Just to put to try to illustrate. Don't forget, before now we have done enough of examples. On elementary of what mapping. I've told you that mapping can also be called function. Don't forget that you can call mapping function. Now, and I think f of x, this right where the polynomial, when I'm having the f of x equals to 2x squared plus 7x minus 8. Now, this is mapping. Now, if I have f of n would be equals to 2n squared plus 4n minus, this can be 0, x raised to power 0 is possible. That is what I mean by mapping. Now, but if I want to explain it very well, you must understand what is called domain and codomain. Now, domain and codomain. When we talk about domain, this is called domain. This is called codomain. Now, we have what we can also call it image and pre-image. Image and what? Pre-image. Now, and I've told you earlier that A, B, C. Now, 1, 2, 3. We have this called. Now, this is a very good example of what f to what to f. This one can be d to what to c of d. Now, that is what I mean by what by mapping. There are types of them. I think I've mentioned that in our previous video, which is we have what is called subjective. We have onto mapping, one-to-one mapping, and we have what is called inverse mapping. We have what is called bijective. I think yes, bijective. To be bijective, it must be subjective and injective. I think injective and now we have done all this in our previous video just in case you need help. Just go to the video 1 of mapping. You'll be fine with it. And also in mapping video 2, we work on inverse part and the composite part of what mapping. Inverse mapping is that when f of x is given to you as 2x plus 7. Now, what will it be? The what? F inverse of what? Of x. That is what I mean by inverse of mapping. And also the composite, when I have fg of x, and those are the things that but this is a bit advanced. It's a bit advanced, which by the end of the video you will understand. Now, that is why I will need to start from definition of mapping. Definition of what? Of mapping. If somebody asks you to define mapping, this time around is not for elementary. Those videos are somehow elementary, but you need to understand the concept before you can go to linear mapping. Now, when I'm talking about definition now of linear mapping. Now, what will I do? Now, let U and V over K, or field K anyhow, a mapping of F to U to V is called a linear mapping. Linear mapping. If it satisfied the following condition. Now, the first one, fu plus w will be equals to fu plus fw. And 2, f of c u will be equals to c f of u. And 3, that 3 just combination of, the 3 is not very necessary, is a combination of the 2, which I can say that, don't forget, before I talk about the 3, let me declare, u, w are what? Are vector. Y, my c belongs to what? Scalar, which I can say that, let me declare as a scalar, which is a field. Now, and 3, I can say that what? F of AU plus BW can also be equals to F of AW plus F of B. No, this is going to be U, sorry. U and W, which can also be interpreted as A F of U plus B F of W. Now, don't forget, A comma B belongs to what? Scalar, and U comma W belongs to what? Vector. That is what I'm talking about. If it satisfies these 3 conditions, it means that kind of things can be referred to what? So, linear mapping. Linear mapping. Now, and I think with this, I have a question here, which the question says, let me try to cite the example. Example now. This is the definition of what? Linear mapping. Now, let me now use this definition to tackle this example. Now, the question says, let f of R2 map what? R place be a map of f xy equals to 2x plus y, comma y. Show that f is a linear map. Now, it's a very simple problem. I think due to time, I won't go beyond this anyway. I think by the end of this, you should be able to understand. What I need to show, I don't need to stress myself. I will check on these 3 conditions. The 3 conditions are so important at this point. Now, how do I go? The first thing I will look at is that I will look at, okay, if I say that suppose, suppose U V belongs to what? R3. I mean R2. R is prime. When U equals to A comma B and V equals to S comma Y. What I will just do now, suppose I'm not let, this is a suppose. Now, what I will just do, I will now say that what? U plus V will be equals to A comma B plus S comma Y. A comma B plus what? S comma Y. Now, I can say that what? In terms of that, I can say that A plus X comma and what? B plus Y. Now, can you see what I'm trying to work on now? Now, I can now continue by saying that what? Come back to the f of x. F of x, which is equals to what? 2x plus y, comma what? Y. 2x plus y, comma y. Now, I will now interpret this in terms of what? My u and v. What I will just do is that this will be equals to now this will be equals to 2a plus x plus a plus s plus b plus y, comma b plus y. Hope you are not lost. Now, I think I'm trying to generate something very good for you, which is I'm just walking along. Now, since I think am I saying the right thing? I think yes, I'm doing the right thing. Now, what I will just do now, but note, but my f of u plus f of b will be equals to f of a, comma b plus f of s, comma y. Now that is now by definition. By definition. Now what the f of the definition tell us? Definition will now come back to where the question is. It means I'll be talking about what? My f of bracket of 2a plus b, comma b plus f2x plus y, comma y. That is by definition. Now, if I should interpret this, is that I will do something like this. I think I'm not making a mistake. No, I think I'm not. Now, I will now continue by having this and this will be 2a plus b plus 2x plus y, comma b plus y. Yes. B comma, yes, I think I'm very correct. Now, can you see this satisfies 1 and 2? This, I'm not making it. Now, it satisfies what? 1, it satisfies 1, equation 1 and 2. It satisfies 1 and what? And 2. Now, I want to move on to the next one, which I need to. Don't forget, just say that if C belongs to what? K, which we have done that, and V belongs to what? R2. Now, and then F of will be equals to F of, I think I'm now working here. Now, F of that is equals to that. Now, what I need to do now is that I will go back to where I'm coming from. It means I will have F of C x y will be equals to my F C, comma cy. Now, since I have this, I will now say that by definition, it means my 2. Now, my 2 of cx plus cy and comma cy I can put my F here, will be, since I think I'll be having that. Now, this one, I can now say that what? My C, my F, 2 of x plus y, 2 of x plus y, comma what? Y. Can you see? Yes. Now, since I have that, I can now look at what? My C of F, x, y, is also the same thing as what? C of F. Now, that is all. That is what I want to generate. Hence, F is linear mapping. Map, or wherever it is. Or mapping. Let me just, F is linear mapping. That is all. That is all. Okay, and I think I have no time to gain. Due to this, I think you can see how it's being done. I will be stopping here for now. Don't forget to share this video and subscribe. Don't forget Further Solutions Academy. On the next video, I'll be working on the transformation and other parts. Once again, thanks for watching.